All right, welcome to lesson 4.2. This has to do with proportional relationships, the constant rate of change, and we're looking at the independent practice. So let's get to it. The first question we have here is information on car rental companies. So I'm going to zoom out just a bit and include all that information. And let's see, write an equation that gives the cost y of renting a car for X days from rent all. Okay, so here we go. And what we need to do is we need to find the unit rate. That is, if I come in here tighter, it is how much money does it cost for 1 day. Maybe I should extend this out, and we would have for 1 day. How much is that? Well, to find that out, we have to take 5550 and divide it by 3. I'll do that over here. 55.50 divided by 3, that is 1, 3, 25, that's 8 times, that's 24, 15 is 5, and 0, $18.50. $18.50 for 1 day. So we're going to use that. And we have over here, we'll call it what? The cost is going to be y is equal to $18.50 times x, which is the number of days. Next, what is the cost per day of renting a car from A1? Well, let's look. A1. The cost y of renting a car for X days is $10.99 for each half day. So if that's for a half day, we need to double that. So 10.99 times 2, that's 18, that's 19, and 2. That should be $21.98. So what is the cost per day? That's $21. So $21.98. Okay, which company offers the best deal and why? Well, this right here is the cost for 1 day from Rental. This is the cost for 1 day for A1. And then we also have to look at here. So what we're doing is we're comparing. I'm going to highlight this here. So we have $19.25 for 1 day for Cartown, $18.50 for Rent All, and $21.98 for the A1. So we're looking for the cheapest price. And it looks like Rent All is the winner because that's the lowest daily rate. So it would be Rent All. And because it has the cheapest daily rate. Okay, the next question is number 8, and it says a skydiver jumps out of an airplane. After 0.8 seconds, she has fallen 100 feet. After 3.1 seconds, she has fallen 500 feet. Empties, I think, says the skydiver should fall about 187.5 feet in 1.5 seconds. Is her answer reasonable? Explain. Well, what we need to do is we need to take, I'm going to make this smaller here, and we need to take these ratios. We have feet per second. Okay, so that would tell us the speed, feet per second. And she goes 100 feet in 0.8 seconds. Now I got a calculator here, and 100 divided by 0.8, that's 125 feet per second. That's the speed. So let's compare the next one. It says that after 3.1 seconds, so after 3.1 seconds, she goes 500 feet. And let's see that. So that would be 500 divided by 3.1, and that's 161. 161.3 feet per second. And she said she should fall about 187 point. So she should fall 187 feet in 1.5 seconds. Let's do that one. 187 divided by 1.5 is 124. 124.6 repeating. So is it reasonable? No. No, it's not reasonable. The Skydiver's rate of speed isn't constant. So, meaning we have the Skydiver's going 125 feet per second, and then later is speeding up to 161.3 seconds. So it's going faster, and she's saying it's going to be slower. So the rate is speeding up, not slowing down to 124.6 feet per second. So there you go. And the last thing to say is the relationship is not proportional. So it's not moving at the same rate. So you can't really put a number to it so much, at least at this level. All right, so moving ahead to number 9. In this problem, Stephen earns some extra money babysitting. He charges $31.25 for 5 hours and $50 for 8 hours. Explain why the relationship between how much Stephen charges and time is a proportional relationship. Well, to figure that out, we have to find the rates. I'll move aside here, and what we have is $31.25 for 5 hours. And so if I divide that, I have my trusty calculator here, $31.25 divided by $5. That is $6.25 per hour, so dollars per hour. And then if I take $50 divided by 8, that is also $6.25, so dollars per hour. So why is it a proportional relationship? It is proportional because the rates are the same. At $6.25. Oops. Okay, let me change that up here. $6.25 per hour. And then explain what the constant rate of change means in this context. Well, it means it means that, by the way, what is the constant rate of change? The constant rate of change is the $6.25 per hour. So it means that he charges $6.25 per hour. And then write an equation to represent the relationship. Tell what the variables represent. So here you go. Tell what the variables represent. So x represents the number of hours he babysits, and y is the amount that he charges. So our equation would be the amount he charges is $6.25 times the number of hours, or y equals 6.25 times x. So how much would Stephen charge for 3 hours? Let me do that under here. To get that, we would take our equation, y is equal to 6.25 times x, and we'd have 6.25 times 3 for the amount of hours that he works. And that's what, $18.75. So how much would he charge? He would charge $18.75. Next up, we have a submarine dives 300 feet every 2 minutes and 6,750 feet every 45 minutes. Find the constant rate at which the submarine dives. Give your answer in feet per minute and in feet per hour. So we got to do both. Okay, so let's do this work over here. And we have 300 feet per 2 minutes. So this is feet per 2 minutes. That means if I find out per 1 minute, I don't have to do per, I want to know per minute. Okay. So that means that if I divided this by 2, I would have to take 300 divided by 2, which is 150 feet in 1 minute. And if I did, I mean, I don't have to do this, but 6,750 feet in 45 minutes, 45 minutes, that also would be 150, because 6,750 divided by 45 is 150 feet per minute. So, find the constant rate. Okay, I found it. It's 150 feet per minute. Give your answer in feet per minute and in feet per hour. So there's the feet per minute. Now, feet per hour, I would have to multiply, because this is how far it's 1 minute, and there's 60 minutes in an hour, so I'd have to take 150 times 60. And I got my calculator here, so 150 times 60 is 9,000. So it's 9,000 feet per hour. Okay. Let's look at number 14. Let x represent the time of the dive, and let y represent the depth of the submarine. Write an equation for the proportional relationship using the rate in feet per minute. Okay, so y represents the depth. So the depth is that rate of change in feet per minute, which was 150 feet per minute, times x, the number of minutes. So that's your equation. Let's draw some conclusions. If you wanted to find the depth of a submarine during a dive, would it become more reasonable to use an equation with the rate in feet per minute or feet per hour? Explain your reasoning. So it would be feet per minute, because a submarine would stay submerged for hours, but it would not dive for hours. It would just dive for minutes. So you would use the per minute rate. For number 16, we have this problem. We're going to make a conjecture. So we're going to use some past stuff and try to project something in the future. So there is a proportional relationship between your distance from a thunderstorm and the amount of time that elapses between the time you see the lightning and the time you hear the thunder. Okay, so they're already saying, hey, expect a proportional relationship here. And if there are 9 seconds between lightning and thunder, the storm is about 3 kilometers away. If you double the amount of time between lightning and thunder, do you think the distance in kilometers also doubles? Well, the fact that they told us a proportional relationship, that means we can make a proportion out of it. So if it's 9. Oh, I was doing this in black. So if there's 9 seconds for every 3 kilometers, and they say it's proportional, then if you double the amount of time, so let's double the amount of time to 18 seconds, would the distance double? Yes, it would, because it has to be proportional. So if you double this, you have to double this to keep it proportional. So the answer would be yes, because the relationship is proportional. And so the distance would increase by the same factor as time, as the amount of time. Okay, let's look at number 17. And that says, let's communicate some mathematical ideas. A store sells 3 ears of corn for $1. They round prices to the nearest cent as shown in the table. Okay, here's our table. Tell whether you would describe the relationship between cost and number of ears as a proportional relationship. Justify your answer. In order for it to be proportional, the ratios would have to be the same. So how about, and it doesn't matter if I take amount this divided by this or this divided by this, it's going to be the same. Since I know that 0.33 divided by 1 is 0.33, I'm just going to go with that. So I'm going to go 0.33 divided by 1 equals 0.33. There's that ratio. I'm going to make this bigger here because I really want to emphasize this. Let me erase so I can write that neater. Again, I did the bottom number, 0.33 divided by 1 equals 0.33. Let's do it here. 0.67, the bottom number, divided by the top number, what's 33.5 equals 0.33.5. Oh, 0.335, sorry. 0.335. And then 1 divided by 3 equals 0.33. Okay. And 1.34 divided by 4 equals, I got a calculator here, 1.34 divided by 4 is 0.335. So is this proportional? I would say yes. So let's go here and we'll say yes. But even though the rates in the table are not constant per ear of corn, there is a constant rate for every 3 years. And so what we could see is for every 3 years. So if we look here, check this out. Every 3 years. So 1, 2, 3. So these are the same rate, and I'll highlight that right here. So these are the same, and these are the same. So it seems like every other year you have a constant rate right there. So that could be proportional. If we just go from here to here, those are proportional and these are proportional. And so that would be okay for that. It's pretty darn close too. I mean, you're round to the nearest cent right there. You're pretty close right there. So anyway, that's it. That's all I got for you. I hope this has been helpful. Thanks for watching.